Okay, in this next section, section 9.6, we're going to talk about solving rational equations. And so let's review, what is a rational equation? Well, we have a rational expression is an expression in the form p divided by q, where p and q are polynomials and q cannot equal 0. Why can't q equal 0? There you go, it'd be undefined. A rational equation that's different is an equation that contains at least one rational expression. To solve rational equations, we're going to identify the lowest common denominator because that's what we needed to have in order to add fractions. We didn't really talk about adding fractions. We need the lowest common denominator. We're going to multiply each side of the equation by the LCD. Then we would simplify, solve the resulting equation, and check the answer. The reason why you check the answer is because sometimes you have extraneous solutions. What is an extraneous solution? It's basically a solution that you get by doing the right amount of work. You get it in a legitimate way, but then when you check it, it doesn't work. Usually it's because you would solve and then it would give you 0 in the denominator. Does that make sense? It just basically means it doesn't work for the equation. Okay, so actually here, this is really a linear equation. So what is the lowest common denominator? 15, good. So if we multiply by 15 here, by 15 here, and by 15 here, basically we're multiplying every single term by 15. What will happen is you can cross cancel, right? 15 over 1. I can do whatever I want so long as I do the same thing to both sides. So how many times does 3 go into 15 if I cross cancel? So I get 5 times 2 times x is 10x, correct? How many times does 5 go into 15 here? So I have plus 3 times x is 3x. And then equals, sorry, I wrote over the equal sign. Can the 13 cross cancel with the 1? That doesn't even really make sense, right? The denominators here are 1. So what's 13 times 15? 195. Glad I have some human calculators. Okay, how would I solve this for x now? Yeah, how would I do that? Well, this is just a linear equation, you guys. This is x, x. These are like terms. How do I get x by itself now? X equals 15. Okay? And then if I do my check will look like, I'm going to take that x equals 15, I'm going to plug it in. 2 times 15 divided by 3 plus 15 divided by 5, is it equal to 13? Well, let's check and see if it is. So here we get 3 into 15 is 5. 2 times 5 is 10. What's 5 into 15? Is that equal to 13? Yes, 13 equals 13. It checked out. Okay, so really what you should do, if you're watching the video, I would suggest you stop and you try the next problem. But we're going to do it together right now just to keep it continuous. So again, this one is going to be linear, you guys. These are linear because you don't have any x's in the denominator. Those are going to be a little harder, so we're going to get to those next. Okay, so what's the lowest common denominator here? 20. And how'd you get that? 4 times 5, right? Okay, so if I multiply both sides by 20, that means I'm going to multiply every single term by 20, both sides of the equation. Okay, and so we have 20 over 1. We can cross cancel. 4 goes into 20 5 times. 5 times x is 5x. 5 goes into 20 4 times. I have minus 4x equals, what's going to be on the other side? 40. Good, because you multiplied 2 times 20. Now we solve. What do I get when I solve? X equals 40. Okay, that's my solution. I can put it in set notation. X equals 40. Should have done that over here because it worked out. That's my set notation. I'm going to do a check. And to check it, I'm going to plug it in. 40 divided by 4 minus 40 divided by 5. We want to know, is that equal to 2? That's 10 minus 8 equals 2, and 2 equals 2. That checks out, and so that means my solution really is 40. Okay, now this gets a little more complicated because you see here we have variables in the denominator. We have to consider what is the lowest common denominator with the numbers, the coefficients, and the variables. So when you look at the coefficients, what's the lowest common denominator, or LCD, of the numbers? 4, yes. And then what's the lowest common denominator of the variables? It's going to be x squared. Why is it x squared? Well, because why is it 4? Because 2 times 2 is 4, correct? It's the same kind of idea here. If I have x, that's not enough because I have an x squared here. What times what gives us x squared? X times x. So I need both of them. It's kind of like when you were saying the lowest common denominator between a fourth and a half was 4. That's the same thing if I said x was 2, then 2 times 2 is 4. That's x squared. Do you see that relationship? No? Because if I say that x equals 2, then how do I get 4? Squared. So I have to have everything, all of the stuff involved in the lowest common denominator. So I can't just have x because it's not big enough. It's like, what's the lowest common denominator between 25 and 5? 25, right? So if x is 5, then in order to get 25, I need x squared. Okay. So now, if I want, there's a couple of different ways I can do this. I can do the same kind of cross cancel here, but another way of doing this is like, what would I have to multiply by in order to get this to have the lowest common denominator of 4x squared? What is this missing? An x. So if I multiply by x over x, I'm basically multiplying by 1. I would get 7x over 4x squared. What is this one missing from? This is missing, so I'm going to multiply by 4 over 4, and I get 3 times 4, is 12 over 4x squared equals, and then what is this one missing? So I'm going to multiply by 2 over 2. That's multiplying by 1. I get 2 over 4x squared. Now, if I were to tell you, okay, I'm just going to do a little corner sheet over here. If I were to tell you that x over 2 is equal to 1 over 2, do you know what x has to be in that case for this equation? What would it have to be? X would have to be equal to 1. That's because if the denominators are equal, then so are the numerators. Notice how the denominators here are all equal. So essentially, if I were to multiply right now both sides by 4x squared, 4x squared, 4x squared, wouldn't these just cancel? Leaving 7x minus 12 equals 2. So that's the equation we're going to solve, right? Essentially, if the denominators are all the same, then you can solve the equation that's in the numerator. So how do I solve that? Okay, so I'm going to add 12 to both sides. I get 7x equals 14. Divide by 7, I get x equals 2. Okay, now if you go ahead and plug that in, do I have room for a check here? I get 7. I'm going to plug it into the original. 7 divided by 4 times 2 minus 3 divided by 2 squared, is it equal to 1 over 2 times 2 squared? You see how all I did there was just plug the 2 in? The x equals 2. That's set notation. I'm plugging it in for x. I get 7/8 minus 3/4 equals, what's that? Yes, 2 squared is 4. 4 times 2 is 8. 1/8. In order to add fractions, I need a common denominator. So I multiply this by 2 over 2. I get 7/8 minus 6/8 equals 1/8. Is that true? Yes, 1/8 equals 1/8. So I just want to make sure that it ends up being true. Okay, now let's talk about this one right here. What is the lowest common denominator? Any ideas about what the lowest common denominator is? What's the denominator, by the way, on the 3? 1. Okay, sometimes people will need to know that because they're like, well, I don't see a denominator there, so that's a good thing to point out. Okay, any thoughts now on the lowest common denominator? Okay, if I were to say that x was equal to 4, what's x plus 1 then? Is 5. What was the lowest common denominator when we had 4 and 5 as our denominators? It was 20. LCD was 20. And that was because we had to multiply them together. So if your denominator is x and x plus 1, your lowest common denominator, wait for it, is x times x plus 1. You with me on that? Okay, so what I was thinking was the easiest thing is let's make them all have the same denominator. If this is the lowest common denominator, which is probably the hardest part, is figuring that part out, what is this one missing? An x plus 1. X plus 1 is a factor, x plus 1. So we have 6 times x plus 1. And that would be over the x times x plus 1, right? What is the 3 over 1 missing from the lowest common denominator? Yeah, plus 3 times x plus 1 equals, what is this one missing from the lowest common denominator? Times x. So I would be multiplying by x over x, and I would have 3x times x. Are you with me on that? I might end up needing more paper in order to show more work, so I'm going to get some paper ready. Okay, I didn't write in here the lowest common denominator because remember that I'm going to end up getting rid of it and just solving what's in the numerator. But I was multiplying here x times x plus 1 over x times x plus 1 in order to give the denominator what it was missing. Now this is all in the numerator. I'm getting rid of the denominator. I cleared the fractions. Does that make sense? Are you with me on that? So now I have, what do I have to do to simplify? Yeah? Why wouldn't it be what? Sorry. Oh, plus 6. It would be plus 6. It just didn't distribute right. That's why. Thank you for catching my mistake. Okay, here we have 3x times x times 1. What's 3x times x? Good. What's 3x times 1? 3x. Okay, it wasn't 1 because I remembered to distribute that time. And then what happens over here? What's 3x times x? 3x squared. Now, as soon as you see an equation that has x squareds in it, that reminds you of what kind of an equation? Quadratic. So you want to set it equal to maybe 0? Do you want to get all your x squareds on one side? So I'm going to subtract 3x squared from both sides. What happens to that? It's gone. Okay, what are my like terms on this side? 9x plus 6 equals 0. Am I doing this right? I rely on you to catch my mistakes. Okay, what do I do next? Yes, and then, okay, x equals, if you reduce that fraction, that is negative 2/3. X equals negative 2/3. Now, I might not be so excited to plug a fraction in for x. So maybe I want to do this on my calculator. Why not? Let me check it on my calculator. And also, I ran out of room for my check. So conveniently, I'll check it on the calculator. 6 divided by negative 2 divided by 3. I'm just plugging it into the original. Plus 3. Okay, I get 2. Let's see if I get the same thing on this side. Okay, and when you do a calculator check, show me that you're doing a calculator check. Okay, you could plug it in, or you could just write 2 equals. Now we want to see if on the other side I get 2. So I have 3 times negative 2/3 divided by, don't you think I'm going to need parentheses for the whole denominator? Yes, I will. Negative 2 divided by 3 is negative 2/3 plus 1. And if I push enter, I better get 2, otherwise I have the wrong answer. Oh my gosh, what did I do wrong? Okay, do I have the wrong answer? Oh, but that should be divide. Okay, well actually I'm going to stop the video and then we're going to figure out why this is wrong. Otherwise it's going to